Hello everybody. Roselyne and I are going to talk a little bit about how we learn during our whole life. So, how your brain works. Know your brain, you can say that there's a dialogue between attention and memory in learning. So, Roselyne, could you share with us a little words about what you are doing?
Yes, thanks, Monica. So I'm a researcher in Washington University in St. Louis, in US, and I'm studying the development of children, like normal development or abnormal development. And I also started a non-profit organization that's called Community. And I don't see the screen anymore. Yeah, and so this non-profit organization actually bring together teacher, clinician, and researcher together to create pedagogic tools that will try to explain cognitive and neuroscience concept to the public and especially to the young public. And one of the main projects that we have in Coengineer is Oceana. Oceana is actually a teaching kit that provide tools for teachers to talk about neuroscience knowledge, how the brain work, and how the brain work in relation to learning and how to learn. So we talk about the basic of neuroscience, memory, attention, emotion, how those relate actually to your autonomy in learning and to how those interact with your learning process. So this tool is available in multiple languages. It has been already widely used in more than 4,000 schools and over 10 countries. And we are still continuing improving those tools for school with new knowledge coming from the lab. And what's interesting is that I was really happy to meet you, Monica, because you have quite similar interests coming from a different line. So can you explain?
Yes, just in a few words. Well, my journey was different. Um, and what I could start with the question, what do you know about long life learning? Well, that's exactly my point of view. My name is Mónica Rodrigues, and I am a neuroeducator. I started as a teacher at university on geopolitics and geostrategy and war studies, but at a certain moment I discovered the brain and well, it started to interest me much more. So I moved from a career in university to start another career, and in which subject? Well, in psychology and neuropsychology. So now I am that moment I'm finishing my cycle of studies in psychology and clinical neuropsychology. I do quite a lot of things. I work with children with dyslexia and attention deficit disorder. I am also a research and business consulting at Mindflow, which is a small technological startup which is specialized in gamification, the learning. And I am also starting a position as a professor at National Administration Institute. So it's quite diverse what I do nowadays. And I could also say that I work with three main organizations, non-profit organizations in India, in Portugal, and also in Nigeria. So I'm developing also like Roselyne, I'm developing a set of tools for teachers and children, and I am starting to develop my learning management system platform with artificial intelligence, with a new methodology that can speed up our work. So if I could start, I should call now Roselyne to say a few words about our brain.
Yes, exactly. So we wanted to talk today about memory and attention. And to talk about that, we need to start from the basic of the brain and what is made of. So the brain is, we know, made of neuron. Monica, if you can just stop the video.
Yes.
And
okay.
Perfect. So the brain is made of neurons. We know that. And they exchange information that are electrical or also chemical by sending information from one neuron to the other along their long prolongation that we call an axon. This axon will connect to other neuron on their dendrite. You can see that on the schematic. And in fact, one neuron will receive a lot of information from different axons and will integrate it through the dendrite. But those connections, those neurons, which are really important to exchange information, are not working alone. They are surrounded by other type of cell that we call the glia cell. And they will help the neuron. They will guide their axon to make new connection. They will feed them. They will surround their axon with an isolant, the myelin, that will help the information go faster. So now, can you start the video, Monica? Yes. What I wanted to show in this video is how neurons and the long prolongation are actually constantly looking for new connection. They will look around, prospect around, and make those connections. Well, if one connection starts to be used because they exchange information and it's useful, well, this one will get strengthened in time. If one connection is not used in the network of connection, it will just disappear, be reused. And it's in this video, you see an accelerated recording of those neurons, and you see how they can move and make connection between them all the time. So the brain is learning during the entire life. There is no time where we are better at learning. Our brain is flexible at all time and all age. That's really important. So let's move to the next slide, Monica, to see how it works with the entire brain. So now we're looking just at specific neuron, but in fact, the brain works all together. So if we see an information, so when you look at a movie, you will actually also memorize it a little bit. And how does that work in the brain? So you see this image, you will have a visual input that will go through the optic nerve straight to the back of the brain, and where this information will be processed. Maybe you will process the border of object, the contrast in the image. This information might be sent up to the parietal area of the brain, where we are going to locate information, spatialized information. This information can also go down to the temporal area, where we will actually compare to knowledge that we know about different objects and categorize what we are seeing. We are seeing eyes, we are seeing a nose, a hat. Well, this is a face. And we actually have an area in the brain that is processing specifically faces and record all the faces that we ever have seen. In that context, we recognize Johnny Depp. And with the rest of the surrounding context, information coming from the parietal area where we localize information, well, we will maybe sort those things out and recognize that we are in the movie Charlie and the Chocolate Factory. This will actually activate knowledge that we know about this movie and its story. There is a chocolate factory, there is helpers, the Oompa Loompa, no? And they actually only eat chocolate. Those information are linked together in a network of information surrounding that movie and just seeing that face. This information pre-activates when we're in a context because we need to quickly recall this information, processing it to be able to understand what is happening in the movie. So now, Monica, let's move to the next slide and view
Exactly.
the
So concerning learning and attention, what could I say? We could start with three basic questions. What is first question? What is the basic role of attention in learning? Second question, why is attention focus so important? And third question, how can we become so efficient learners during all our lives? Well, this model on attention is based, it was modelized by Posner, a really very interesting researcher on memory and on attention and executive functions. And we could say that there are lots of attention models, and basically you classify attention depending what you are studying. But for learning, we could say that there are three networks most important that helps us to learn. The first one is the alerting network you use during all your day to be alert to what happens around you. The second network is the orientating network that allows you to orientate through the objects all during all the day. And finally, the third is the executive attention network that helps you to decide. So basically, what could we say? Attention, decide, select. Well, why is attention so important? This was our first question. Three main ideas I could share with you that can help us to understand the importance of attention. The first idea is that what is attention? Attention is basically the capacity you and I have to determine which information or which stimulus is encoded. Second main idea, attention not only helps you to determine which information is encoded in long-term memory, but also how it will be retrieved. The third main idea is that we know that the response and the task selection are clearly internal processes. So either you are a person with that can organize, direct your attention toward goals, you can focus your attention and it comes from the inside, or you are a person that you can't drive your attention through a focus, a net focus, and you are completely distracted for what is going around you. So, in conclusion, we can state that internal attention includes, from one side, a cognitive control that makes you decide your priorities, which perceptual information you encode and maintain in your working memory, while at the same time you suppress distraction. And this is most important because the process seems to be affected. This process of cognitive control and suppressing distraction seems to be affected in disorders like attention disorder, deficit disorder, and hyperactivity disorder. So, schools, teachers have the fundamental role regarding developing a goal-directed attention. And how? Using strategies based on curiosity, motivation, or student personal interest, because those who succeed with these strategies can help develop attention as an internal process in children and in students, and let them motivate them to play in solving the problems. So now the second question is, why is attention focus so important? Well, now that I got your attention, I would like to share with you another three main ideas. First, when you select an object, you discriminate features like color, movement, shape, connecting occipital structures with temporal structures. Second main idea, you identify the components. Third idea, you discriminate components, you identify the components, and you build a category. And at the same time, you are building a neural network to identify animals, objects, faces. That is basically what Roselyne does with her machines. So, concept, we categorize, and finally we transfer. And how? Well, you pay attention to an object, like this beautiful panda, for instance. You discriminate its components and you build categories. You put the animals in the animal category and you put the hamburger in the food category. And finally, you transfer this process to other objects, like shoes in this case. So after you train this process, and again, the teacher has the most important role in this process. Basically, you must stress that you pay attention, you need to describe and discriminate the features, and you learn the components, you put the components all together, and you build categories. And then you go deeper as you can. Deeper organization, what you are learning, and transfer again. So how will you succeed as a long life learners? Well, it is a little bit more complicated than this. We are just trying to simplify. But basically the rule is, if you pay attention, you categorize successfully. You establish relations among objects, more and more complex objects, maps, and you can do your concept maps, and you are able to learn during all your life. Isn't it, Roselyne? What do you think about now? She is going to speak something about memory.
Exactly, because you are talking about working memory, and so let's go back to what are those type of memories that we are using. Because those map of concept are the storage in a long-term memory, and to arrive there, you need to start from the short-term memory. So the shortest that we have is actually the sensory memory, the one that is just the one that we can replay a little bit when we have not paid too much attention, but actually we can still repeat what we just heard. So it's few seconds of memorization in the auditory system, maybe in the motor system as well, tactile system, or the visual system. This is the first processing of information, and then this information will be sent to working memory. And in working memory, it's a memory that is still short-term to manipulate information together. For example, when we do math, we need to subtract, we need to hold in memory few items and manipulate them together. While in a problem solving, we will also need to compare information that we have from the past, that we know, to the problems that we have in front of us to try to find a solution. This is also based on our working memory. But this working memory is not fully extended. Like we can only manipulate 7 to 9 items depending on individuals, depending on also our age. Children can only manipulate less even than 7 items. Once this information has been used in working memory compared to what we know already, we are going to try to store it in long-term memory. So let's go to the next slide, Monica. And this one, I want to point out that actually long-term memory is can be also of different type. So can we? Yeah, perfect. So in long-term memory, we have a non-declarative memory. For example, procedural memory, learning to walk, learning to bike. This one is quite permanent. Emotional memory is also about experiencing things, is also quite permanent. It's really strong, it doesn't fade. Maybe the next time that you want to cycle, you want to go on your bike, it's been a while that you didn't bike, but you will still be able to do it. You remember how. You don't need to learn again from scratch. In long-term memory, you also have the declarative memory, and this one is about being able to tell something. So talking about an event that has happened, an episodic memory, or the semantic memory that is about concepts that we have learned. Well, this one fade, and we need to reactivate it. We need to learn again, study again. It will start with encoding information, and we need to store this information. And when we want to use it, we need to record this information. Well, those different mechanisms, we need to actually train them and study them multiple times. So you see the forgetting curve here in blue. Once you first learn, you will then start to forget about this information. And if you don't study again, you will forget. If you study it, it will fade less quickly, and so on. So memory is not fixed forever, we need to study. But Monica, you have some tricks now.
Yeah. Now let's talk about the tricks. So you have to start with attention focus. You should draw mind maps, a lot of mind maps. Minimize distractors around you, and you can also engage in attention training program in the classroom with your teacher. Then I called it the Maturowski effect. Why? Because you describe, you identify the components, and then you start organizing in a hierarchical procedure the concepts. Finally, be a rebel. How? A learning rebel, of course. Ask questions. Ask questions all the time. Be constructive in your classroom. Rebel for life learning. And Roselyne, I think you have some tricks too.
Exactly, and they goes well together. So tricks to improve the memorizing. Well, we saw that there is multiple mechanism to memorize. The first is encoding, and as you said, for attention, you need to minimize detractor. Why? Because your working memory is the first step into the long-term memory, and you can only have 7 to 9 items. So don't get distracted on the way, and also highlight main information that you want to learn. The secondary information, the detail, put them for your second pass. Wait a bit. Focus on strengthening the first level, and then you will make connection with your secondary information. In the storage, we have seen that we make connection with previous knowledge. So to do that, when you start to learn new information, first refresh what you know about a certain topic, what we call the prerequisite. So refresh this information and then build logical links between them. For example, well, you have those helpers in the chocolate factory that are the Oompa Loompas. They actually live in the chocolate factory. So what is available to them around them is chocolate. So they might eat chocolate. This is a logical link. You can also generalize information by seeing it multiple times, refresh information, or maybe see it in different contexts will help you realize that this information is important, and your brain will generalize, strengthen the connection, strengthen the encoding. Then we have the recall, and most important, the recall is another mechanism, and you need also to train it. So if you read an information, you think you know this information because you have read it already, this is not enough. You need to close the book and make sure that you actually can repeat this information. Otherwise, you can't know if you can recall it actively. So you need to test yourself. And you also need to use the logical links that you have built for your storage to be able to recall information easily. So those are my tips related to memory. I think I was really happy to do this presentation with you, Mónica, and I'm really looking forward for collaborating now that we know that we are so much on the same page.
Exactly. As you stated a few days ago, in your birthday, on your birthday, well, 2020 wasn't that bad enough, so bad as we think, because we met together, we have a lot of opportunities to the future, in the future, and we must stay positive. This is really, this was really a wonderful invitation from Microsoft. I'm really pleased for having been invited, for having met Roselyne, and I think we can help Microsoft build the next future, a brighter future. Thank you so much. Thank you, Roselyne. Thank you all.